Imagine planets, drifting alone in the dark, without a parent star to orbit. These are starless planets, mysterious, lonely worlds floating freely through space. For decades, astronomers have been baffled by their origins. But now, a new study might have just cracked the code. Published in Science Advances, a groundbreaking discovery by an international team of astronomers reveals how these strange wanderers, known as planetary-mass objects, PMOs, may form through a completely unexpected process: collisions between circumstellar disks. So what exactly are PMOs? These are celestial bodies with masses less than 13 times that of Jupiter. Too small to become stars, yet too massive to be regular planets. They drift across galaxies, often found in young star clusters, like the famous Orion's trapezium. Until now, scientists thought these objects were either failed stars or planets ejected from their solar systems. But that explanation never quite fit. Why are there so many of them? Why do some appear in pairs? And why do they move in sync with nearby stars, as if they were born in the same place? To solve this mystery, Dr. Deng Hongpeng and his team from the Shanghai Astronomical Observatory ran high-resolution simulations. What they found was astonishing. When two young stars, each surrounded by rings of gas and dust known as circumstellar disks, pass close to each other within about 300 to 400 astronomical units, their gravitational forces interact in dramatic ways. Massive tidal bridges of gas stretch between them, twisting and collapsing under their own gravity. Over time, these bridges fragment into dense clumps of gas, compact cores that can grow massive enough to form free-floating planets. These new worlds are not ejected planets. They're born this way, formed in the chaos of colliding disks in tightly packed star clusters. The team's simulations even showed that up to 14% of these PMOs could form as binary or triplet systems, explaining why some are found traveling together through space. Even more fascinating, PMOs retain traces of their parent disks. Some even have miniature gas disks extending up to 200 AU, suggesting they could host their own moons or subplanets. Think about it, a planetless planet with its own mini-solar system, floating alone through the galaxy. Their chemical makeup also offers clues. They form in the metal-poor outer regions of disks, where heavier elements are rare. That means their atmospheres may look nothing like the planets in our solar system. The research, a collaboration between scientists from Shanghai, Hong Kong, and the University of California, Santa Cruz, could reshape our understanding of how planets form in the universe. Future missions aim to observe PMOs in other clusters, checking their chemical fingerprints to confirm these findings. So, could this mean that millions of unseen planets are silently drifting through space waiting to be discovered? And if these worlds can form without stars, could life ever exist on one of them?